Hello, so today we are going to do Leetcode day 21 from Leetcode 3-day challenge. Today's problem is subarray sum equals k. So the problem says given an array of integers and an integer k, we need to find the total number of continuous subarray with sum equal to k. So we have an array of integers and an integer k, and we need to find the total number of continuous subarrays with sum equal to k. Okay. So for example here, k equal to 2, we're going to find the total number of continuous subarrays that sum to 2. So we have this one, that gives us 2, these 2, and that gives us 2, and only these 2. Continuous here means it's contiguous. It can be like, can't have gaps, right? And the length boundaries are between this interval here, and the values are between -1000 and 1000. Okay, so let's see how we can solve this problem. So one idea that comes to mind here is sliding window, right? Where we could, so we want k equal to 2, equal to some value. Let's say 2 here. So what can happen is we start I and j at some position, right? At the same position here. And we keep moving j until we reach k. We count it, right? But maybe like we may have something like, let's say 1 here and then 0. So at that point, what we need is we need to still keep going. So we keep going. So for a window, we can keep going until sum is bigger than k, right? At that point, we need to move j. So when we get here, the sum is bigger, so we move I here, right? And we subtract this, right? And then we check, we count this again, we move j again, now we are out. But there is one problem. So when j is out, the window is no longer valid, we should move I. Okay, I think this should work, but let's think if there is a simpler solution. What if the brute force solution would be to just go through every interval, right? So that would be 2 for loops, and for each interval check the sum. If it's equal to k, then put the value, then count it, right? Equal to k though means maybe we could use a hash map of each value, right? So what if we keep track of the value and its index, right? Okay, so let's try this solution. It seems promising. So I, j will both start at 0, and then while j, that what advances, we want to check if, so we want to current sum, right? That's 0. And then, well, that starts out as, so one thing here, if yep, so the array is at least of length 1, so we don't need to check for empty. So what happens here is that we want to either expand or shrink the window, right? So when do we expand and when do we shrink. So we definitely shrink the window when the current is bigger than K, right? So if that's the case, we want to shrink, which means we want to do I plus 1 and subtract. We all need to handle boundaries here. And when should we expand here? If and current here is going to be plus. Maybe not. We will need the counter, right, for the number of occurrences, right? So if current is equal to K, we want to count. And then we want to say current plus the element at position J, and we want to increment J, which means here we want to say 0. At the end, we want to, of course, return count. So if count value is equal to K, we count. If it's small or equal, we expand the window. If it's bigger, we want to collapse, shrink. So we subtract the count here. The problem is when we exit, right? So we will need to advance if J moves, right? So maybe we should say length of nums, right? I'm thinking of this to handle the case. Let's say we have 0 values and we want all the subarrays that sum to 0. Well, in that case, we wanna, even if J like moves past the end here, say here, we still want to keep moving J, so we could keep moving I, so we can count this one, for example. And so what that would mean here is that, or, and then here we could say, let's put this as an end value here. And J less than N. Yeah, there's a problem with this. Oh yeah, the problem is current, right? So okay, yeah, this is starting to get complicated. So actually, I think this approach won't give us won't be very useful. Let's try something else here. So what we want is an interval, right? An interval I and j, such that basically we can sum of j minus sum of I equal to k, such that the sum here is the sum from 0. So sum of I is basically equivalent to the sum for the range from 0 to I, right? So if we did this, then what this means is that this is just equal to k minus this, right? Because this here, k is the sum of both. So if you subtract one, you get this one. So what this means is that if we can have a map of sums that keep track of the count of sums seen so far, that's pretty much would be all we need, right? So to do that, let's just have map sums map. Let's call this collections default dict int. And what we want is to go through we want to have, so this is the start, right? Or let's call it I in the range of, say n is the length of the numbers array, and then here we want to track this sum here, right? So so let's say sum of j was 4 and sum until I was 2 and k equal to 2, right? So this should be equal to 2, right? So what are we looking for? So what this means, so this is sum of j equal to 4 and sum of I equal to 2. Does this work? So sum of j here, which is 4, that's actually 2 plus 2. But 2 here equal to 4 minus 2. So this would be say that sum of I is equal to sum of j minus k. So that's actually what we are looking for. So s equal to 0, and we'll keep going. So plus nums of I, let's call this j. And if sums map contains s minus k, that means that we have okay, let's actually just do default dict. So if we have this in the map, we could just say count. Let's declare count here. Would be sum of map occurrences of s minus k. And what we want here is to add this sum to the sums map. So sums map of s minus of s is going to be, we're going to increase that by 1. actually is going to be, so if S not in, I want to initialize it. So we add the sum, we check if that exists, we count, we add it, and then we return the count. Okay, it's still not working. So here for this array, let's see why it won't work for this one. So we'll come here, right? So first j is here, sums map is empty. And so s is going to be equal to 1 and k is equal to 2, right? So we'll look for 2 minus 1. We won't find that. Okay, it's actually not this. Okay, so yeah. Let's go back here a little bit, yeah. Okay, so with this, we will have something like this. Okay, so actually, let's simplify this. Let's make this into a counter. Use Python's counter. So from collections, import counter here, and let's just go through numbers. And s would be plus num, and then here we will just instead add whatever count of these sums we had so far. So counter of s minus k. If it's not there, it would be at 0, right? So that should be fine. And then we want to say counter of s plus 1. Okay, why does it still say 1? I think there's a problem here. It's weird that it's saying that that doesn't work. Oh, sorry. It's still saying 1. Let me just test if this is even makes sense. I'm returning 5 here. Okay, so that works. Okay, so I think I know why. So the problem here is that for 0, like there is no value, but 0 should be considered existing, so we should add 1 here. Okay, that does looks like it, because otherwise for value 1, let's say this one here, we'll find that there is nothing, right? So that's not what we are looking for. Okay, so let's submit this. Okay, so that's accepted, yeah. So pretty much it's just this counter here to count occurrences of sums s minus k, which what we said earlier sums up until the end of the interval. Minus k should be equal to the sum of the beginning, and that's what we are using here.